Let's jump right back in. I want to take as much of today and give you a chance to try this out on your own. I just want to recap our rules for the derivatives in case we missed it. And just like really just give you a chance to try it. I'll just kind of do the work as we go. And if you get stuck on anything, if you want to talk through anything, we'll have the day that really just kind of try this stuff out. It's really the kind of thing where I think if you just get your hands dirty and try it out and you see that you're getting it right, then you feel really good about it. So our two rules for our natural exponential. So just as a recap, if it's just e to the x, what's the derivative of that? Ah, that's my favorite. It's so amazing. Cool. But if it was equals e to the anything else, like some f of x, so whatever was given, leave it, right? Don't change it, and then do what? Times f prime, times the derivative of the exponent. Good. Okay. Now, sometimes that's all we had to do, right? Like the first one, the second one, even the third one that we looked at yesterday, it was just e to the f of x. Okay, cool. So e to the sine of x times cosine. Or e to the 2x plus 3 times 2, and then we just kind of reorder things up. But I think we get to the fourth one with the product rule. 2x plus 3 times e to the 3x. Okay, cool. Right, so sometimes, like as you're working through it, sometimes it's not the whole thing. You know, sometimes it's part of the product rule. But okay, cool. I have a base of e. That makes it a little bit easier to work through. That was what 214. Page 214 is where we kind of kick things off. Is that right? And I think like we didn't get down to those bottom two, right? That's kind of where we'll start. Our practice will be at the bottom of 214. Top of page 215, we'll do that as well. But again, I just want to recap what we know for ln of x. Oh, no worries. The natural logarithm, if that's our function, ln of x, what's the derivative of that? 1 over x. And what that really like shows us, and this is actually, I remember this one, and then it helps me remember this one, that if the argument of that logarithm is just more than just x, again, it's a fraction, it's going to be rational, no logs, which is really, really nice, no x warrants even, unless it's part of f of x. What's the derivative of that? Yeah, derivative on top, original function on bottom, which clicks right here too, right? The derivative over the original. Cool. F prime of x over f of x. And then, like, simplify if you can. Move stuff around, make it look however you want to make it look as nice as you think it needs. And the thing that I think is just going to help you really, like, kind of, not necessarily master it today, but maybe, but at least feel really good about where we're at, is to just jump in, okay? And so the pages that I want us to try to do today, if we can, we'll see how far we get. Keep this in mind, 214 and 215, okay? That's kind of the initial practice for both, okay? 214 and 215. And then there's additional practice, which I think is worthwhile, on 218 and 219, okay? I'm going to hopefully in the next 40 minutes, because that's how much time we've got right now, I'm going to try to do every single one that we haven't done, okay? I will do the work. I'll give you a chance to take a peek or take a picture if you didn't quite get as far as quickly. But I'm going to go all the way back to 214 and start there. Starting with, I think, just the two on the bottom. Is that correct? We did 4 on this page. We haven't done the last 2. Okay, cool. So I'm just going to start right here. And if you want, go for it. You don't have to wait for me. You feel like, okay, I know my derivative rule. I'm just going to see if I can do it. Try it, okay? I'll just give you a little clue first. The first one, bottom left here, product, okay? The second one, rewrite the function first. Okay? And then The time is yours. Like, just try it out. You can talk to each other. You can talk to me. You can talk to nobody. Do whatever you think you need to feel like you've got this stuff. Because this is like between today and tomorrow, maybe Friday, we're done. That's it, for sure. And then we'll kind of figure out what we want to do after that in terms of any sort of end of chapter 3 assessment that you might want. And then just check your answers as you go. I think for a lot of these, there's some fluidity to the kind of answers that you want to write down. Factored version versus not. The order that you write stuff in, as long as it's equivalent, I'm good. With the bottom right one, I could do it this way and go chain rule style. All right, drop the 1/2 in front, leave the inside the same, decrease the power by 1, and then multiply by the derivative of the inside. But I've got an even better idea. Exponents, raise the higher exponents. What do you do with those two? Multiply them. Okay, cool. E to the x minus 3. Way easier than trying to do chain rule, which, of course, will get you to the right answer. But once I rewrote this as e to the 2x minus 6 to the 1/2, oh, 1/2 really goes nicely into those two, which is even better. There's my f of x. Here comes my f. Now, I'm just a little curious. What would happen if I just chain ruled it instead? In base, subtract exponents, multiply. Same thing. A lot more work done. We should get the same derivative no matter how we do it. I actually had a few people that said, no, like, I really know the product rule. I don't want to rewrite it as a polynomial. Can I do that? Can I choose to just use the product rule when I see a product? The answer is yes. Anytime you want, you can use any approved differentiation style that works for you. Just find the one that you think is the path of least resistance, which is definitely the blue over the green. Yeah, I'll leave this up for just another moment or two, and then I'll start doing afterwards. Top page 215, which will be the quotient. Now sounds good. So yeah, 214, 215, 218, 219. Those are the 4 pages we're going to try to get all of them done right now, if you can. Monomial denominator, let's expand that so we can use it for some fun. I see some fact. Top of page 215 right here. Folks at home, if you have any questions. Wait, are you in 20 or 21? What desk number? I know. Smelly board. All the wrong. One more minute with this one, and then I will work on the initial logarithm ones, which are really nice. Usually they work out so nice with the logs. There's no logs right now. If you are not to this one yet and you want to hold on to this solution, take a picture of it now so I can move on. But just BD minus. That's all it was, and then alpha. The calculus doesn't last very long, right? Once we get to the derivative, now it's just some algebra. Okay, here we go. Again, ask questions of each other, ask questions of me, whatever works for you. Can I get all four of these? Yeah, I can sneak all four of these in here. Derivative on top, function on the bottom. And derivative on top, function on the bottom. Hey. Thank you. Indubitably. Now, I think we did those two, right? Did we do those two yesterday? Just the first one? Cool. Nice. Yeah, it's just derivative on top and then function on the bottom. The inside argument there. And sometimes you can simplify, sometimes you can't. In either of these cases, there's really not much for me to do. We did the bottom left one, right? With the negative tangent. We got to do. So that one's really nice as well. Derivative on top, negative sign. Function on the bottom. So that's negative tangent. Super nice. And again, this one, I'm going to rewrite first. And whether you write it like that, or if you feel like you really need like an inside kind of feeling, like to put the big set of parentheses around that, that's okay. The blue parentheses are not necessary. It's understood that the 1/2 is attached to the 2x minus 4 because of the parentheses that are there anyway. But for those of you that really want to make sure you're playing it safe, that's cool. And if I leave it like this, I need the chain rule to do the derivative of the inside. So I'm going to do it that way, and then I'm going to pause, and I'm going to show you something that maybe you remember from last year. Chances are you don't. That's okay. I'm going to do this derivative two different ways. Okay, derivative on top. So chain rule, drop the 1/2 in front, leave the inside the same, decrease the power by 1, multiply by the derivative of the inside, and then the bottom is just the function. I guess I'll go this way. Okay. 2 and the 1/2 are gone. This moves down to the bottom and becomes positive. 1/2 in the exponent. Same base being multiplied. Add their exponents. One over 2x minus 2. That's the hard way of doing this problem. There's an easier way. And it comes back to a property of logarithms that you definitely were taught. Whether or not you learned it or recall it is a different story. Let's see if you remember. You have a log, and the argument has an exponent. You remember what we can do with this exponent instead of just leaving it in the exponent? The property of logs that says that this logarithm and another one are equivalent, and I can do something with that one. Let me ask you, did you guys like expand and condense logs with different properties? Like, oh, I have two logs being added together so I can multiply their arguments, things like that. Same thing with subtraction, you can divide them. Right? Yeah. It's not a huge thing, but it does come into play with things like this that say, you have a log, your argument has an exponent, it is equivalent to taking that exponent and dropping it in front. These are the same. Now I don't need to change it. Now when I find this derivative, let's stick with the green so we know what we're talking about. It's the derivative of a constant times a function. Okay, cool. So I can just pull that constant out in front and worry about the derivative of just the ln part. So 1/2 times, okay, oh, it's ln. So I have my little rule here. Derivative goes on top. Function goes on bottom. 2, 2. 1 over 2. Really nice. Properties of logs were pretty useless when you just learn them as properties. Why am I expanding and condensing? This. Either one's great. If you don't catch the property, if you don't notice that one. I think it does come up once more, I think on 218, 219. Again, feel free to skip 216, 217. Although there are good application questions in there, if we do have some free time, I'd love to come back to those. Because exponential functions are a great way, and logarithmic functions are a great way to model things changing. You'll see how they do that. But this does come up again with the whole 1/2 thing, so use it. It's a good one. Doing good on time. So that should be 215. In a moment, I'll switch to 218, 219. All right, here we go. I'll get rid of this. Is that cool? 216 is good. It's a calculator thing where they give us a function and ask us to find the derivative at a certain spot. And then say, is it increasing, decreasing? Does it have a horizontal or vertical tangent line? Just to kind of get us back in the mode. But they're trickier functions at not so nice answers potentially. So we let the calculator do the work. And then what I mentioned yesterday, I keep trying to mention as often as we can, 217 starts to talk about the derivative being more related to rates of change than slopes of tangent lines. Okay? Number of people entering a concert can be modeled by this function. We can use a function like that to figure out, when are people showing up, how fast are they going in and out, all that good stuff. That's really, really helpful. A cup of coffee, temperature in a cup of coffee. A lot of exponential and logarithmic growth there. All right, cool. Here we go. 218. You can like that or factor it up to you. Negative exponent there, take care of that. Ooh, 3. Ooh. E to the x ln of x, that's a product. I'm going to take my time here and just say, here's what I'm going to do. E to the x ln of x times the derivative of the exponent. I'm just going to slow myself down here for a second so I can do u and v. 1. V is 1 over x. Besides e to the x being its own derivative, ln of x being 1 over x, that's not going to work. So. All right. So e to the x ln of x times the product. Ex ln of x times 1 plus 1x. Distribute if you want. Leave it factored if you want. Feel free to distribute there. You can if you want. You don't have to. V plus V U. Make that a little nicer. Let's factor out e to the x. Put the rest in standard form. How about that? I like that. You could just multiply, write it out. That's cool too. I noticed the e to the x in common everywhere, and then what's left over is kind of nice. But again, lots of different okay versions here. I think 1 and 2 are pretty much set. Not much we could change about them. H and G could be distributed. That's cool. I'll leave those up for a moment. Again, take a picture though, because it won't last very long if you want to hold on. Nothing to submit with this. This is just practice. We've got a lot of homeworks and classworks in there. I'm going to dilute it. Not sure if what you're doing is okay, you want me to come look at it, whatever. Questions that are good for everybody, or questions that are just good for you. You gotta tell me what you need. Like I said, we're done with chapter 3 at the end of this week. Once we get to, what are we, 218, 219, once we get to 220, we're just gonna look at like the rest of the exponentials, and all we have to do is multiply by a constant. There's this constant we're gonna multiply by with 2. Same thing with the logs that are just anything but base E, base 2, base 3, base 7, base 10, whatever. We just have to multiply by a constant. So I actually decided to factor out the e to the x that I saw that was in common between this term and this one. So there it is factored out, and then I looked at what was left. 2x squared plus 3 plus 4x. I just put them in a nicer order. 2x squared plus 4x plus 3. But kind of the step that's happening in between here that I didn't write is like me distributing like 2x squared e to the x. Plus 3 e to the x. Plus 4x e to the x, right? There's an e to the x everywhere. And this would have been fine. Cool, done. Not necessarily in standard form because this is x squared. I should probably put the x1 next and then the 3. But that's cool, right? Distribute like that. This is kind of gross. I would probably do something with it just to make it look a little bit better, which could be this. But then I was like, oh, okay. I'll factor out that e to the x and see what I have left. So I'm good with this one. I'm good with kind of reordering this one so the 4x shows up right there instead. Okay, so because my exponent is more than just x, I have to multiply by the derivative of the exponent. Right? So e to the whatever, leave it exactly the same, and then multiply by the derivative of it. And when I wrote my first line in blue there, that's all I wrote was e to the whatever times the derivative of x of the exponent. I kind of like wrote out what I'm meaning to do. I only decided to do that because that derivative of just the exponent is a product. I need the product to just do it. Now I could have like jumped to this line right away and said, okay, e to the whatever times, okay, now I got to do the derivative of what's up there, do my u, v, du, dv, because those are just going to go right there. I decided to write the step in blue to slow myself down a little bit, because I knew that second part of the derivative where I need the product rule just to do it, it has its own kind of like different mindset. Oh, I got to get my u's and v's going. And so I played it a little bit safer, slowing myself down so I don't make it. I say, okay, here's what I plan to do. I'm going to leave the function the same. I'm going to multiply by the derivative with respect to x. I'm kind of laying out a course for myself to do not all of it all at once, but kind of like slowing myself down so I can focus on just the product in the second, rather than trying to do it all in one shot and maybe make a mistake. So that first line in blue, absolutely optional for sure. I just thought it was like this function was complicated enough where I thought maybe it would be good to slow down. But that's a personal choice. how fast do you want to go, right? When I did my work here in red, I didn't write this. This is happening in my head. I could write this and slow myself down and really be careful. You know, maybe I'm feeling good and I just get after it. So there's a level of comfort that kind of plays a role into how many steps you think you need to show to really feel confident that you've showed enough logical steps and it's right. And there's some gray area there, which is kind of frustrating sometimes. But. All right, 5 and 6 coming. Yeah, the excess anymore. Logs, derivative of the inside, and then leave it the same. So 2 e to the 2x. For 5? Derivative of the inside. There, pull that out front. Ooh, but I can distribute it and make it even nicer. I like that one the best. I'm not going to leave the negative up top. I'm going to pull it in front, but ooh, look at that. I can then multiply it into the bottom, which switches the order of stuff. That's fancy. Yeah. That worked out real nice. So, okay, ask, talk to me.
I've never seen that. I mean, I get how it works, but I wouldn't know the thought of that.
Yes, okay. As long as you understand why, it's okay that you don't see that. I'm happy to take the answer right before that, for sure. For me, what makes it worthwhile is the denominator wasn't in standard form, right? It was backwards. It's negative 2x plus 3. And so if I can absorb negatives in order to reorder subtraction, it's kind of nice. Not critical. Yes. Absolutely.
Oh, wait. No,
So what I think would be helpful for you to remember where all of rewriting as ln of 1/2 equals 1/2 times ln of 2. So a couple steps where you rewrite the function, and then you'll do that. All right, I'm on to 219. I'll do 7, 8, 9, 10, and then I'll do 11. Rewriting this one just like we rewrote the last one. Again, property of logs there. Much easier. Right? 1/2 times derivative of the constant times the function. Just pull that constant out. Fraction through the inside and then the inside. 5 over Leave it factored or distribute. Either one's cool. I guess I'll distribute. Why not? There. Ooh, quotient rule. Nice. Oh, I can see where this is going. I got a feeling I got some rational simplifying to do. Let's see how it plays out. V du minus u dv all over v squared. Let's see. Let's distribute. 1 minus 2 over x minus ln of x over x minus 2 squared. Complex fractions. Make common denominator and bring it down to the bottom. Also known as, even easier to see maybe, let's multiply top and bottom by the denominator of the top that we want to get rid of, x minus 2 minus x ln of x over x minus 2 squared. Create the common denominator. X over x minus 2 over x minus x ln over x, all over x, and then move down to the bottom. Or eliminate the complex fractions by multiplying top and bottom by that common. Questions about 9, let me know. 10. And then for our last couple minutes, we'll do 11. Quotient rule again. I just love derivatives are so nice. You guys are becoming derivative masters now. I love it. This is it. These are the last couple of rules. If you're taking the derivative with respect to x and the only variable is x, you got it. This is it. That's the 3 rules of differentiation. This is it. Now, I'm going to talk a little bit while you finish things up. I'll do 11. I'm just kind of really looking ahead. They do talk about the derivatives of inverses in here. I will probably just give you the rule just for your own good, but we're not actually going to practice it. It comes up so rarely that I'm not going to stress too much about it. I'd rather get to the good stuff in chapter 4 because there's lots of good things that I want to talk about. Some things I definitely need to hit before we get out of here. 4 weeks or so from now. So, and then that's it. Chapter 2 is done. So we'll learn a couple of the other rules later tomorrow, and then we'll practice it on Friday. I got a late start Friday. Okay, keep that in mind as kind of wind things down during any week that has a Friday. We'll be a late start Friday. So. I'm about to erase this, so if you have any questions, now's the time. If you want to take a picture, now's the time. 9's definitely the hardest one, I think, on here out of these 4. Just because getting rid of the complex fraction. But multiplying top and bottom by the common denominator that you want to make will erase it. Get rid of the common denominator. Should get rid of fractions on top and move that common denominator to the bottom, which is where it belongs. Cool. 11. Equation of the tangent. Oh, you would. You rapscallion you. All right, here we go. You do that. I'm going to do this. Equation of the tangent line. So this function, ln of x over 4x, I think. And x equals 1. Nice. So I need the equation of tangent line, so I got to do derivative. One last quotient rule. 1 over x or y dx. du minus d all over d, okay? 4 minus 4 ln of x over 16x squared divided by 4, 1 minus 1 of x squared. Okay. I need a y value, so I'll call it y1. I plug in 1. ln of 1. ln of 1 is asking the question, e, the base, to what power is 1? The answer to a logarithm is always an exponent. Okay? You're asking the question, e, my base, whatever it is, to what power, that's going to be my answer, gives me 1. E to what power, e base, to what power is 1? Good, there's y1. I need a slope. That's me plugging it into the derivative. 1 minus 0 over 4 is 1/4. Down. Y minus y1 equals 10. X minus x1. That's cool like that. You can drop the 0 and write it like this. You could distribute and write it like this. I'm good with anything in blue here. These are all good. How'd you do? You do okay? Was this good? I want to do stuff like this. I think it's helpful. So yay, masters of derivatives. Love it. Have a great day. You don't have to submit anything. This is just for your benefit. Nothing to do for tomorrow. I'll see you then. That's our regularly scheduled programming tomorrow. Homeroom. Don't forget.
Mr. Rosengren, Mr. Rosengren,
What's up, Ashley?
what